Hi. So here we have our first problem that we're going to try to model as a network. And let's read it, that the catering company must meet its daily demand for clean napkins by either buying new napkins or using regular laundry service, so it doesn't buy new but it gets cleaned once, which require a full day turnaround, or special overnight service, which comes back the next day. Supplied with the demand for each of the next 5 days and the cost for new napkins, regular laundry service, and overnight laundry service, you have been asked to develop a model which will minimize the cost of procuring the napkins over the next 5 days. The company currently has no napkins in its usable condition, clean or dirty, on the premises or at the laundry. So we need to have some symbols because we don't want to have so many words. So let's make up some symbols for the data. So let Cn be the cost of buying new napkins. So it's $1 per nap. And I guess the cost of regular laundry be cost of regular laundry. And again, $1 per nap. And then CE be cost of express laundry and $1 per nap. We also don't have the demand, so let the demand be demand for napkins for day I. And that again is going to be in dollars. That's going to be in just napkins. Now we need to have a drawing for this, a graph for this. So we need to make sure we have enough space. And let's see what this might look like. Well, all of the napkins are going to come from someplace. Let's call that the new napkins, the new node. And then we're going to have to provide each of the days. So this will be day 1, day 2, day 3, day 4, day 5. And we're going to have to decide how many we buy. Now, this is very key in these network models, is that we write the limits where they belong. So there's no explicit limit in terms of how many napkins we can buy. So we're going to say this is 0 infinity, and we're going to pay Cn for every new napkin. That's what we defined before. Now, once those napkins arrive, what happens? This is where we have a problem. And the problem is that we don't know where to put the demand. I think we will know how to, when you transfer things from napkins from one day to another, you'll be able to assign a cost of cleaning. But where does the demand belong? So demand belongs within 1 day. Now you might be tempted to put the demand between the first and the second day. It's going to get confusing. You need to deal with the reality that napkins are either clean or they're dirty. And you only make them clean as you need them by sending them to the laundry. So we need to have the idea of clean napkins and the idea of dirty napkins. And once that dawns upon you, then it becomes clear that you're going to have another node, which is going to become your dirty. So I'm going to have a DD1, a dirty day 1, and a dirty day 2, and a dirty day 3, and a dirty day 4, and a dirty day 5. And then I'm going to have the demand is going to be the number that the clean ones that become dirty. And that's where my demand is. I'm going to get this many dirty. And same thing for all the other days. Now, in terms of getting them cleaned, I can get them cleaned either quickly or slowly. I can get them quickly by joining these two nodes, and there's no limit how many I can get clean, so I'll put infinity, but there is a charge, and that's the express charge. So each of these is going to have the same arc that will cover the express cleaning. But they're also going to be a 2-day cleaning, which is my regular. And I'll put that label somewhere down here. It's understood that all the others are labeled the same way. Now, what happens after they become dirty? Do they have to become cleaned? They don't have to become clean. I can just decide to put them aside because I will never need them again. My demand is very large on the first day, and after that, that's a possibility. I may want to discard them. So since that one's called new, I'll call this one old. And this means that they're just taken out of the system. Now at the end, I have no other place to go. These napkins cannot be cleaned. These can only be cleaned express. And the limit here is 0, infinity, 0. There's no charge, no consequence, no limit on how many I can throw out. Now, this is where our circulation flow comes in with a label of 0, infinity, 0. That all my old napkins, I will have as many napkins in the old bin as I will have to buy from the new bin. Think about it. If I need 32 napkins to feed my demand, that's how many are going to be dirty over the entire period. And that is the model for this problem. Now, one more thing. I'm going to be minimizing costs, so I have to put a label of min.